Let's do another numerical for resistors combination, but this time we have to find the value of current. I have a resistor this which is in series with a parallel combination, right? And they are connected with the source. Let us say this is 6 volts. I am taking any random value, 3 ohms, 6 ohms, and this is 2 ohms. I want to know what would be the value of current flowing through 3 ohm resistance. Okay, so what exactly is happening? Suppose whatever I amount of current flowing in the circuit, this current is going to get distributed when the current faces a parallel combination, right? So this current will be bifurcated into I1 and I2, right? And then the current will recombine to form the main current I, and the same current will come back in the circuit. So this is a simple formula that whatever current leaves the circuit comes back in the circuit, or whatever current leaves this battery will come back exactly the same. So even if it is 4 ampere, it will be divided into 2 or 2 or 1 or 3. It will entirely depends on the value of resistor. Remember a sentence that current seeks the least resistive path. Current seeks least resistive path. That means current will be more at a point where there is less resistance. So by just looking at the diagram, you can always say that I1 is greater than I2. Okay. Now let's solve. First of all, to find the value of I1 and I2, I'll have to know the value of current I, that is the main current, and to do that, I'll have to solve the whole resistance of the circuit, right? So let's start. The combination parallel 1 upon Rp. Parallel thing is 1 upon 3 plus 1 upon 6. It's going to give me 2 plus 1, which is 3 upon 6, 1 by 2, 1 upon Rp. So resistance in parallel is equal to 2. Reciprocated. This is 2 and that is 2. So that gives me, you got my point, that this whole is resistance in parallel, which is equal to 2 ohms. So this 2 and this 2, the combination and this 2 are in series right now. If you are still not getting my point, this circuit can be redrawn like this. Okay, 2, 2 and 6. This is what I was saying. So resistance in series would be 2 plus 2, that is 4 ohms. So 4 ohm is the total resistance of this circuit. Okay, so total current would be total voltage upon total resistance. Total voltage is 6, total resistance is 4. That gives me 3 upon 2 or 1.5 amperes. We can solve further using this value or that value. Anyways, I will try to neglect the decimal thing. I am going to use 3 by 2 only. It just eases the calculation. That is it. Now, see what actually is happening. I'll tell you. When I redraw the circuit, it is easier to explain the distribution of voltage in the circuit. As I told you in series and parallel combination thing, that whatever voltage has been applied here, we have applied right now 6 volts. So this 6 volt is going to get consumed throughout the circuit. That means this might have taken 1, this have taken 4, 5 or 3 or 3 or 2 or 4. They can take any values depending on the value of resistance, but the point is the 6 volt is going to get completely utilized in the circuit. Okay, so I am going to calculate what voltage did this resistor took V1, and I am going to calculate what resistor this resistor took, that is V2. So V1 would be equal to current into resistance. What is current? The current flowing through the main current is 2 ampere. This is 3 by 2 ampere. So we already know the main current, which is 3 by 2 amperes. So the 3 by 2 into 2, using the formula V is equal to IR, right? Current flowing through this resistor is 3 by 2 ampere and the value of resistance is 2. So 3 by 2 into 2, that gives me 3 ampere, right? No, 3 volt. Okay, so this is 3 volt. 3 volt has been utilized by this resistor. That means 3 volt will be utilized by this resistor as well. So they in parallel combination, they have actually used 3 volts, right? Now, so 3 volts in parallel voltage is always equal. So 3 volts is supplied to both this and this in parallel voltage is equal to, this has also received 3 volts and this has also received 3 volt. So now we can calculate the value of current, which is I1. How? I1 is equal to V upon R1 and I2 is equal to V upon R2. I don't want to write the value of I2, but I want to explain another point. So first of all, let's calculate I1, which is V is 3, resistance, R is also 3, I'll get 1 ampere. And here V is 3, R is 6, I'll get 3 by 6, 1 by 2 or 0.5 ampere. The point I want to explain, we have already done this formula, that we have already solved this numerical, that I wanted to calculate the value of I1. I've got the value of I1, right? I want to tell you another thing, that what is I1 plus I2? This is 1 plus 0.5, which is 1.5 ampere. And what was the total current? 1.5 ampere. So total current will always get bifurcated into 2 parts or 3 parts or 4 parts, but the total sum will be exactly the same as the main current, right? This is how you solve series and parallel circuits.